Hello everyone, welcome to my series on Matplotlib, which is a visualization library in Python and is built on top of NumPy arrays. This cross-platform library is so much popular because it supports dozens of backend systems as well as various kinds of output. In this series, I will be talking about how you can create plots, how you can save them, how you can retrieve them back, how you can create legends, how you can change parameters and update your visualization. So there are a lot many things which I'm going to cover under the series. So I would say subscribe this channel and stay tuned. Getting started with today's topic. So today we'll see how we can create and save basic plots using Matplotlib. And as an editor, I'm using VS Code. So let's quickly jump onto the VS Code. And the very first thing which we need to do is we need to import the required package. So for that you can say pip install matplotlib. Doing this will go ahead and install the package for you. For me it is already installed, so I'm not going to do it again. And once the package is installed, you need to go ahead and import it. So we can say matplotlib dot pyplot, and let's alias it as plt. Next we need numpy, so I will quickly alias it as np. Okay, so the very first thing now we need is we need to define our axis, what all things or what all numbers we want to plot. So for that I'm taking a variable name x, and using numpy I'm going to create the random numbers which we are going to plot. So here linspace will take few parameters. The first one is the starting one. Second is what is the last number, till what number you want to plot, and how many number of samples you want to take. So let's say I want to take 70 samples. Okay, so once samples are taken, we need to say what we want to plot with these numbers. So I will quickly go ahead and plot some sine and cosine charts. And here we need to say x is my input parameter, is the number from which you need to grab all the data, and then we'll say sin sine, which will take again x as a parameter. Similarly we will go ahead and do for cosine. So for cosine it is cos. Okay, so once it is done, the only thing which is remaining is we need to show the plot. So we will say plot dot show. Let's execute it, and you can see that two plots are shown over here, and the starting one is 0 and the last number is still 10, and these are the random 70. Here we have defined 70, so these are the 70 samples which are taken into consideration. Now if you're looking at it, you are not able to identify which line signifies what, whether it is sine or it is cosine. So how we can differentiate them. So for differentiating them, we can just add one more parameter here. So here I will say when it is sine, just show using hyphen, and whenever it is cosine, we will show double, or we can say star. Okay, this we will show. Let's see now. You should be able to see star for the cosine, and the blue line is your sine wave. Okay, now at this point you can see some stars in this format. Let me go ahead and change the visualization a bit. So I will just apply some styling to this plot, and you would see that there is a difference. So first of all I will show you a C-bond. Okay, there are various kinds of styles which are available. You can go and explore the documentation. You will get a whole bunch of available styles over there. So this is how it looks in C-bond. Now if I will change it to classic, you may notice that there is some change in the way stars were displayed. So let's change it to classic. And this time stars are actually looking like stars. So this is how you can play with styling part. Next thing is we will see how we can go ahead and save this visualization which we just created. So for saving this visualization, there are various formats. Okay, let me try with one. Okay, now whatever we have plotted is directly on the screen. So in order to save it to a file, we need to collect all these things and put it into a container. So that container is called fig, or you can say figure. So I will say fig as a variable. You can take any variable name, and then we'll create an object of type figure. So now figure will contain your data, your x-axis, your legends, whatever is part of that visualization, everything will be in your fig. Okay, so once fig variable is created, we will go ahead and say fig dot save fig, and in this you can give some name, my fig dot png. Okay, no need to show it, and we can even get rid of this styling part. Just give it few seconds, and here you can see that figure is saved, and this is how it looks like. So this is the file which was created. Now next thing I want to show is I'm using here png, but there are many other formats. So to know which all format it supports, what we can do is we can create a variable, let's say formats, and we can call a function name get supported file types. That is on canvas. So canvas that get supported file types. I will go ahead and print this formats. So here you can see in my terminal that these are the various formats which are supported. So PNG, PS, RAW, TIFF, PDFs, JPEG. So there are many things which you can do. I hope you enjoyed this short video, and stay tuned for my next videos in this series. Thanks for watching.